All right. It's the 10th of December, 2024. Hey, everybody. This is the second session of Aiken PBL or Aiken PBL live coding from SIDAN Labs, Gimbalabs, and friends. Really excited to be here. I had the privilege of giving the first lecture in this course last week, and today I handed off to my partner, Hinson. And you've already taught this stuff, haven't you? Like out in the real world?
Yep. In the Hong Kong Cardano Developer Series, we have kind of covered it, though it is not as structured as right now. It's more of a free flow back than 2 months ago. Yeah, but the content pretty much we have covered already once.
Really exciting. So yeah, thanks. Hinson and I had a chance to draft this course material back in September for that in-person Hong Kong developer series. And now we're really excited to be bringing an updated and refined version to this course. We meet on Tuesdays at 14:30 UTC. The link to this meeting is at gimbalabs.com/calendar. We'll drop all of those links into the notes below this video on YouTube. And while Hinson is teaching today, I'll drop a bunch of links into the chat right here as well, and we'll take on monitoring the chat. But should we jump in and see what happens?
Yep, sounds good. Let me check the course. Okay, I think I got it. Just have to manage the screen sharing a little bit. Okay.
Looks good here.
Is it the best way to navigate it, or I
And
could
if you
use?
go to the little globe icon, yeah, exactly. So we can look at the published view. And can you just take us back to the home screen of the course for a second on the left side, Aiken Project-Based Learning? All right, so last week we covered module 101. Today it's module 102. But for anybody who's getting a little bit ahead, you can see that the release date for modules 103 and 201 is today. So those are live as of a few hours ago. And these live coding sessions will be trailing the release of the written modules by a little bit.
Yep,
All right.
sounds good.
So we're going to write our first smart contracts today.
Yeah, for today's content is actually not that much. This is the outline of the today's content. We'll probably cover the two basics validator, which is the mostly used type of validator in Cardano development. First is about spending validator. This is a validator that we will love to use in locking access, locking data for the dApps and so forth. The second one is for the minting. Like for example, there's a token that you want to mint, maybe a FT or NFT, or even this is not a user-facing NFT that you just want to use it to facilitating the applications. You will use a minting validators. And then we will also cover a little bit basic on the unit testing on the spending validator mostly, because in the meantime we will check it in a bit. Looks very likely, looks very alike with the spending validators. So this is the outline for today. We just talk about the spending and then the minting, and in an always succeeds format. It's a very vanilla version. There's no check in it. And some spoiler about what we will cover is we'll also run a fail test case for the always succeed validator. It's kind of counterintuitive, right? But there's something that you have to be aware of when you're building the unit testing, or you will panic yourself quite frequently at the time you're developing. So any question or point uh this line? Sounds all good. Since there's no sound, then we jump straight into the lesson 102.1. So on the lesson 102.1, we will cover how to write the always succeed spending validator. So without further ado, let's take a look into the content. So for everything we cover in this Aiken PBL, we have a open public repository storing all the student examples. There's no exception for this module 102. If you want to follow along the course, you could just git clone the repository and go into these directories, and then you will see what's happening. So let's directly take a look into the actual code itself. So this is the always a seed spending validator that you would like to write for your dev development. You can see a few of the patterns. The first very important pattern is about the type signatures. You see that for the spending validator. Firstly, I can get some very good syntax that could help us to identify what's the usage for the validators. So here we could see we are using the word spent here. This is not something that we define ourselves. It's actually following the convention of Aiken. So if you want to write a spending validator, you would like to write spend. And then for example, if you like to write a minting validator, you would write mint. And then there's also a couple of other syntax that's covered by the Aiken. I think you could find all of them in the official documentation about what is the validator types. Yeah, it is here. It has covered most of the, indeed all of the potential validator types and the function names that you could match to your functions. But in Cardano development, we would write a pretty large proportion of our script just in minting and spending. Sometimes if you want to also control the staking part for a little bit, we will also use the rest of the purposes. But for the simplicity of this course, we will just focus mostly on the minting and spending. And this is also the case for now. So yes, let's go back to the validator syntax itself. So now we know that for this spending validator, we want to declare the function as spend. So this is pretty much just like a function declarations. And there are 4 different parameters that we want to put in the or input type signature of the spending validators. So they go into this orders. These are the fields that are required by Aiken if you want to write a spending validator. First is that you have to go with a datum. Second is go with the redeemer. Third is about the output reference, which is the pointers onto your current inputs that you're validating. And the fourth argument is a transaction. In the later part of the Aiken PBL, you might also see something like some more syntax putting extra parameter in front of it, but we are not covering it right now. We're just covering the mandatory field of a spending validator. So if you have declared everything correctly, Aiken will allow you to compile for the script. Otherwise, it will likely to throw you some errors. This is something that you can also check against it. And the second part of the validator is that we will also declare a catch or fallback else functions. So indeed, this is just like when we're writing the Haskell kind of valid function, there's indeed a pattern matching patterns. So when a transaction triggers the script, it will firstly check whether it falls into this spending validator catch. If this is the case, it will run the logic here. If not, they will fall back into the else function here. So for a lot of the convention or even the compilation convention, you can see that even I try to delete this thing, where I save it, I can build this for me. So this is the convention that the Aiken team has been imposing. They just try to make sure that the code base itself actually catch all the conditions. Whether you want to spend, this is a spending validator transaction currently triggering, you fall into here, triggering the checks that you want to check. Or if you use this script for example, a minting policy, it's 100% possible because at the end of the day, it is just a CBOL hash that you attach with the transaction. You compile this and use it as your policy ID as well. And then if that's the case, it will go into the fallback and catch all blocks. So this is just a simplest syntax that you could write a validator. For a lot of the case, you could also just rely every logics in the cache or block as well. If you want this to be used for minting, spending, or everything, or you just like the syntax more than this, you could always just rely on the else block. And this is, if this is the case, this is a script context. It will include everything we have here, but you have to dig into the documentation a little bit to check how to access these fields. But it could also supply everything you need for your transactions. Right now, since you're writing the most vanilla spending validator, we just keep it as it is. So this is the simplest context. And apart from the content itself, one thing that I did miss mentioning is the name of your validator. Although it doesn't affect anything about the validation logic, but at the time when you're compiling your script, you would get this always succeed showing up in the blueprint that you're compiling. So here's the case, like this is like always succeed, and then it's following your file path and then your validator name, which is the name that you just declare, and then the spending part. It will have all the script information that compile for your reference. So you could just name it in any case, like in your convenience, or yeah, just like our standard software engineering, give a little bit of thoughts about naming your validator. It will help you easier to navigate and find out the correct CBOL hash in the compile putters.json. So I give a little pause here to see if anyone got any questions, because the information is a lot just by looking at this simple syntax, actually.
It took me a while to really understand what that else meant because like I knew about else as the opposite of if, right? If I'm writing in JavaScript, I can have an if statement, an else statement. This is true of most languages. But that else right there, it's handling all of the other purposes. And once you really get that part, that gets really exciting. And could you show us just a preview of the minting validator just to see how the word mint replaces the word spend?
Yep.
I know we'll
So
get to
this is the way.
in a second.
Yep. So I will cover the mandatory also inputs for the type signature for this minting function in a bit, but you can see everything is quite similar.
And
Actually, there's a
this one would fail if I tried to spend with it because the spend would be captured by the else.
yep, exactly.
Cool.
Yep. Any more questions about the syntax or how you feel in general? Do you like it or not?
I know we got some new faces, so if anybody's not ready to speak up yet, feel free to drop a line in the chat.
Also opening up the chat. Better than Java and Plutus and Haskell. Yep.
Funny.
Yep. I think so, actually. And the syntax actually it has just changed like 2-3 months ago, as I remember. Prior to that, as at the time I covering in the Hong Kong show, is a previous version of syntax. So it is pretty new actually.
Got even better. Yeah, this is a very responsive development team who's thinking really hard about how to make application development as easy as possible. So shout out to the Aiken team. Thanks for evolving.
Yep. Yep. So let's follow this a little bit. So in case I have missed anything. So yep, I think I missed the import statement that in general you could find all of the type here in the standard library of Aiken if you're going for the development. For example, this is the transaction. Let's say you don't know how to write the import statement on your own, and you know that is a transaction, and what do you do? Essentially, it's very simple. You go into the standard library, the Aiken standard library from their official website, try to search for it, and then you would know that this is under the Cardano / transaction. This is how to find the import syntax for the inbuilt type that you want to import. Yep,
Um,
this is
and,
a
and
Cardano
Emmanuel
/
had a question in the chat just
Yep,
about where to find the body of the function. And so this one, it's a little bit hard to see because the whole body is on line 16 right here, right?
yep. This is a body that is a standard Aiken function. And if you remember our first module, every Aiken function returned the last line. So indeed, this is the last line.
Right. The only line, that's the whole body of this function, but you could have many lines of arbitrary logic in this validator right here.
Yep, this is returning a Boolean here, actually. And this is the last line of the function.
And it's a common
Yep,
design pattern to write helper functions, right? You can import them from elsewhere, which we'll look at later, or you could just write helper functions right here in the same file down below the tests. And then you could pull those in just like you can in a lot of languages.
yep. So we've got another question from Nelson about what is the option serves. So if you remember the early days of the Cardano development, if you ever try to send a lock a UTXO in a spending validator without a datum, your value will be permanent lock. But right now with Aiken, here is the option data type signature. You will no longer experience that once again. So imagine, let's say this is let's say the type signature of data. It is not a option data. Imagine you have sent an UTXO into this spending validator, and then you forget to put the validator. So what's happened when you try to unlock it? When you try to unlock it, it will trigger the script checking. So indeed, when you try to spend a UTXO without datum in this script, it will go into this validator, right? And then first, it will trigger the check about the pattern matching. It will check, oh, right now it's a spending validator, so it is this function. But if you are sending a UTXO without datum, and here since in the type signature, you're specifying there's some data, you will fail the pattern matching. It will directly drop into the fallback and catch-all. And then this is how you would create the permanent lock case about UTXO without datum in the past. But since I forgot which hard fork, you could indeed send a UTXO without datum into a spending validator. So if that is the case, you will do something like, yeah, this is the place that you could catch. Yeah. So this is the case of spending no datum UTXO in a spending validator. And this is with datum. So in Aiken, there is an option type of datum to specify that there's indeed a positive chance that you're locking a UTXO in a script without datum. So if this is without datum, here we is returning a none type. If there is a datum, it will return you with something. Yeah. Just like James mentioned, there's maybe datum.
This is one of those things, if you're new to Cardano development, you don't have to worry about the whole history here. But if you've been around for a little while, this is a really nice thing to notice. It's because you'll know what a big improvement this is over the way things used to be.
Yep. So it's pretty interesting, actually.
Yeah, line 17 is a real relief right there. The fact that we can have
Yeah.
that.
Yep. Since I do want to record this part of the discussion here, so I just comment this thing. I will push it later on in the course, the student example library, native script. Yeah, if you're using a native script, it will never fall into this context. Like there's another validating, yeah, kind of realm that you're going into. This is not a proof of script validation. So you're just using the, for example, inside mesh, you could compile the native script right ahead in TypeScript and define it in TypeScript. You don't have to carry it with the Aiken and everything. Yep. So any more question at this point? We are indeed halfway through the course of today.
What's going on with those tests down there?
Yeah, there's something that we'll cover next. So in Aiken, since if you remember our previous week, we started off everything about testing. So if you recall what's happening in the module 101, this is a scene test that you want to write a test. And then since a test is also a function, it will just return the last line. But if you are declaring it as a test, you have better to just return a Boolean at the last line so that you can run the Aiken check module 101, for example, to check all of the testing results. So if there's the last line is a true, returning a true, it will return you a pass in the testing. So this is something to do with the unit testing of Aiken. And since we know that all of the validator, including the spending validator itself, is just a big Boolean function. So in the last line of our code, we are just returning a Boolean indeed. So we know that we could write unit testing about the validator very easily. We just have to treat this whole thing, this big boy, as a big function with these input fields, and then we know that this function will return a Boolean at the end of the day. So we could indeed just call the function, put in the parameters which kind of fulfill the type signature requirement, and then we know that this is returning a Boolean. So we could still run the Aiken check in our terminal. And then we could see it could trigger a test and returning the testing results. So for this testing result, since we are just calling this function spend, we know that no matter what are the things that we are passing in, it will return us a true, kind of intuitive, right? So this is a way that we write unit testing. And there's a bit of the syntax reminder is that if you're testing one validator you name like this, and want to test the spending block, what you have to do is just the name of your validator dot the purpose that you just declare. So these two, you can see they're essentially identical. Yep. So that's the only thing that you have to know about how to call the function. Then it's about the input parameter. There's something that start to get a little bit tricky because when you try to test your transaction, you know that this is option something. Probably you could provide just a none, as simple as I said. And then this is data So we call a little bit about what is data. Maybe we didn't cover. I forget about it. But a data is actually just a arbitrary data type that's representing everything. So whenever there's a data passing in here, no matter it's an integer, Boolean, or a structured data, there's just a kind of any type of the data in Aiken syntax. So from here, since we didn't declare what is a redeemer, we could by default just use data. And then by using data, you could indeed just passing any type of cat data type. You could also fulfill the criteria. So put into context a little bit, we could go back to the standard library, check the primitive type. Yeah, a little bit. James just sent it out. You could find there's a lot of the primitive types that also fulfill the criteria. They're everything that could be represented by the data type. And then for simplicity right now, we have just chosen one meaning nothing here. There's a data type called void. This representing nothing, essentially, nothing meaningful. So there's something that if you want to pick one for our unit testing pattern, we don't know what to put in, you just use void. Alternatively, you could also just use one for a byte string, etc. Everything works. I will demonstrate in a bit, maybe. So there's a way that you pass in a kind of arbitrary data into your function signature. And then, yeah, Adrian, I see the hand raise. I stop here a little bit.
So that data is the same as built-in data in Bluetooth?
Yep, I think so. Yep. It's just representing everything.
Yeah, I'm pretty sure it compiles to the same place, but want to double check that. But yeah.
Yep. I've quite a while haven't written any Haskell and Bluetooth, but I think they're the same. Yep. So I will continue here. And then you see that there are two big boys here. One is called output reference, and the other is called transaction. So how can we build the mock data type for this output reference and transaction? Because we know that in our spending validator, we are not checking against anything about them. So the easiest way for you to do so is to go into the standard library, same, try to search for exactly what is the type. So this is a way that you could know that what exactly is the output reference. It is indeed a data type which has two fields. One is named as transaction ID. It is a hash of transaction in this algorithm. So how we could perceive this type? So whenever you see hash of something in Aiken syntax, it is essentially just a byte string. And we could, double check with this syntax in the standard library documentation. A hash is nothing more than a byte array. It's just a byte array. Just a carry extra information for readability. So what are the extra information here? The extra information is that this is using the Blake 2B 256 hashing algorithm towards a transaction, and then we got the transaction hash. This is something that we see in Cardano scan. Also, the TX hash, or when we submit transaction, there's a TX hash returning to us. This is the identical TX hash. And then another thing that probably is not too useful when we are building a on-chain code, but good to notice is that this using the Blake 2B 256 algorithm, which means that there's a 32 bytes in length, because the 256 is 256 bits, I think. So essentially in hash strings, you could expect this in a length of 64, and then in byte array in Aiken representation, this is in the length of 32. There's some details that could help you to understand the context a little bit. But in on-chain code writing or building, you just have to know that this is nothing more than a byte array. So we know that the first field of it is a transaction ID, which is a transaction hash. And the second part of it is the output index. So if we record, for example, we go into the Cardano scan, pick a random transaction. This is the transaction hash. And correspondingly, this is the transaction ID in the output reference. And then when you talk about the output index, you can see that, for example, this transaction got 2 outputs. So this is of the output index of 0, and this is of the output index of 1. So for example, whenever we want to spend these UTXO, and this inside a script, and inside the script context, we could access that this is coming from this transaction hash of an output index of 0. So in a conclusion is that this output reference gives you some information about which exactly is the UTXO that the script is currently validating, give you the access of this. But coming back to our, it might have some bit of excessive information, but just coming back to here. So how we could build the output reference. So we know that output reference equals to output reference transaction ID, and then there is something. Oops, did I write something correctly? It has been a while. I haven't written the syntax. Oh, is it just the Copilot suggesting incorrect name? Yeah. It is too smart of an AI. Yep. So this is a way that you can write the output reference. And then I just save it up a little bit. So this is how you could supply a output reference to your unit testing. So I check the chat for a bit. Any question at this point? Yeah, I think the question has been resolved by James. So, yep. This is a way that you could build a mock transaction hash. And of course, if you want to make it to be more real, you could always respect the format requirement. For example, put in the real 64 length of transaction hash here as a transaction ID. I'm using a hash here to representing to indicating this thing is indeed a hash string, but not a byte array, a pure byte array. But you could after you have written this output reference, you will very quickly realize that in Aiken unit testing, it's actually meaningless for us to just try to make up a lot of different values in the byte array. For example, this is essentially just a hash string. No matter you're putting everything's A, everything's 0, it's representing the same thing. Same as the output index. We just since our script is not using it anywhere, so it doesn't make sense or it doesn't really matters to put in different index. So this whole thing, we know that we could mock it. That's why in the Fokker library, we provide several utility functions to do the mocking. For example, this is a mock UTXO graph function that you could provide the first index to represent this is different type of mock. For example, you could say that there's a of the zero index, first index, second index, and it will return different mock UTXO ref and hashing kind of randomly. So yeah, you can make sure that you're using different output reference. And the second input is about the output index. So for example, if I want to just very simply mocking the output reference, I could just use this mock UTXO ref from the Fokker library. So about how to use it and the documentation, there's also in this Fokker source code, you could see there's also a kind of standard library like documentation here listed here. If you click into here, you could find everything you need. So for the mocking, everything we put it into the mocktail module. For example, right now we know that we are mocking output reference. You can find the version output reference. And then you can see these are the functions that you could mock a output reference. And we will use quite a lot of these because when your source code becoming bigger and bigger, you can imagine you can no longer afford to write a lot of these kind of mocking things to pollute your source code. So keep things intact, you could just directly use the mock UTXO ref like this, and amongst other mocking functions. So this is how we could very easily get the mock value of output reference. And yeah, just up to here, any questions? Will anyone find it confusing to use a utility function like this?
If you're ever not sure where one of those comes from, be sure to let us know because we want to try to drop them in at just the right moments when everybody's ready. And hopefully you'll see in the course documentation that we're showing you when these equivalencies are there, and you'll be able to look for that.
Yep. So same, I will keep this snippet here just for everyone to reference these two. We could mock the output reference like this at here. And then the final bit part is about the transaction. Same, following our philosophy, whenever we are not sure what's inside a type, just go into the standard library here. Just go into the standard library, give it a search to check what's inside. It's quiet in here. Anyone cannot hear what I'm talking. Someone's missing the sounds.
Oh, that's the note taker.
Yeah.
The note taker can hear.
I see. Oh,
Got
there's a note
mechanical
taker. I see.
That's hilarious.
Yeah, hilarious. So this coming back to here. So there's a transaction contest. So it's a little bit intimidating, right? So probably we don't have to dig into everything here. After all, we just want to mock a simplest always a C validator here. And in the Aiken standard library, they provide a utility in the Cardano slash transaction just to give us a mock empty transactions. So if we get into the details about what is the empty transaction, we could check here, maybe. Or indeed, if we want to check, we have to get into the source code. Yeah, so this is a source code about the empty validator. Essentially, it's just returning empty of everything. So we know that we could just directly use this placeholder constant, and we will get everything meaningless, but just to satisfy the requirement of type signature of our validator. So there's also the easiest way that we can supply the transaction placeholder. Same, we run the unit testing. We see this is a successful pass. So following, coming back to what I've just mentioned, since it's just a opaque kind of data type for the redeemer, I just change it into several different shape, maybe a byte array, maybe an integer, maybe a Boolean, everything pass. Yep. So yeah, this is a summary of how to write your first unit testing on an always a seed validator. Any questions from the floor? Yep. If there's no question, then we go into the most exciting part about writing a failed test case about our spending validators. So this is always a seed. No one give it a doubt, right? That if we try to check this fail test case, it's just returning fail when we try to call the script. So why? Even we have this denotation about an exclamation mark, which is the opposite of a Boolean. So if this function returning a false, then it would probably be a passing case. So why not this is the case? So it is indeed, if you're spot on, it's not that difficult of a spot, because here always the seed dot spend. We are going into the spending contest here, which is always a seed. But if we are using this script any other purpose else other than the spending purposes, we will drop into this catch or fallback clause, the L clause. And from this else clause, we can see that there's only one liner, which is a fail syntax. So this is how it will causing fail. And then in this fallback clause, indeed is accepting one parameter in the type of script context. So we could mock a script context like this. I won't go into the details about how to build the script context, but if you are interested about the details, same, you could just go into this standard library, search about the type, and then you could build the script context yourself. And this is the easiest way of building a mock contest, and it will pass it into this else check. And it will return us a failed case. So this is a very important moral of the story about writing Aiken unit testing, is that a validator indeed return 3 different types of scenario. First scenario is that there's a true return of the in the Boolean functions, so that when you're expecting a true, it will return you a successful check. Let's check that again. When it is a true, it will return you a true. However, the second type of return is a false. Let's say you have run into some of the check, Boolean check in your smart contract, and it's evaluated to be kind of failing. And maybe your function will just return a false. So if that's the case, if you're expecting a true case in your unit testing, it will give you a fail, because you're expecting this is a true, but it's returning a false. But sometimes you could also build the unit test case where you're explicitly expecting this is a fail case. For example, you're expecting it's returning a false. You just add an exclamation mark at the beginning of it, just indicating it's the opposite of true. When you run that, it's actually still can return you with a pass, even though it's a false kind of return. This is how you could build more, increase your unit testing coverage. However, a lot of people miss this piece of details, is that indeed there is a third scenario in your Aiken script unit testing. Is that apart from running the whole program, the big giant, and returning the last line about true or false, there is a certain case that the program will cause panic in the middle. Like maybe you have some unsafe pattern matching. Then if the program run into this line, it will never rechain the final line of your smart contract, and it will just returning a fail case. So if there's a fail case, so what will happen? Is it no matter you are expecting it is a false, no matter you're expecting it is a false, it will give you a fail test, nor you're expecting it is a true case, it will also returning you a fail. So there are sometimes in your on-chain code development where you build your very awesome smart contract and you have a lot of different test case covering your smart contract. No matter how you adjust your unit testing, try to figure out what's happening, it's always just returning you the fail case. There's a certain good chances that your program just end in the middle, because there are some unsafe pattern matching or any other things else just cause the program to panic in the middle. So neither the program return you a true nor the false. So give you a always failing kind of unit testing result. So this is how we could build a fail test case, always fail case on a always succeed spending validator. And there's some nuances that you would like to know. So I give a little pause here and then we go for the last piece of details about the module 102. Any question from here?
Is there something like a trace error so that you show some error messages if some pattern matching is wrong?
Yep. Indeed, this is a useful error message. From the last time that I used Aiken, it didn't really have this yet. Maybe on this few recent pushes or release, it had this useful traces like the validator crashed, exited prematurely, indicating that your program just failed before reaching the last line, and return really get into the place to a function return. Yeah. Any more questions or comment or anything?
Yeah, I have a question, Hanson, regards to the rapid development of Aiken. So actually you mentioned many times that the syntax has changed and many other changes or maybe even coming. So I was wondering let's say we learn now all these syntaxes and all these test cases, etc. For how long normally we can work on it before going to update or major update or upgrade for our code base or libraries or dependencies? So like how reliable we can say our contract are.
Yep. I think the contract itself is always safe. Like right now, for example, I'm just writing the Aiken in this version. No matter how frequently the Aiken language syntax updated, you will always just going back into this version, the same standard library to compile your smart contract. So no matter how the Aiken team update the syntax or anything, if your local CLI and the standard library version as indicated here, it will never crashes. Like you will just run the smart contract on the Cardano blockchain. Yeah, just I don't think it will crash anytime. Just if you want to keep up with the syntax when you bump this compiler version and everything, you will have to learn about the new syntax. So there are constantly some bit of new improvement coming up from the Aiken team. Though although it is updating quite frequently, I will give them a little bit of the defense because the last time we have this major syntax upgrade that I'm mentioning as for example the spending validator input type signature change is actually happening on the Chang hard fork. They're just coming with the hard fork, adding in a lot of new types and new necessary fields. That's the occasion the Aiken team have a really major upgrade or update on the syntax itself. Other than that, I don't think they will actually update the syntax that frequently, nor you don't really have to catch up that frequently if you doesn't have to do so. Just in the case that you have identified the, for example, major compiler efficiency upgrade that you would like to rewrite everything in your contract, that in normal cases, I think normal usage, you don't really have to keep up to date with the syntax. Yeah.
So the only thing that we need to remember would be, I mean, maybe two things. First, the version of Aiken and the hash of that commit or the hash of that version. And we
Yep.
can work on it
Or
and we can
yep.
say this is constant throughout all the update and upgrades.
Or actually, you don't have to really remember. Like at the time when you're initializing your Aiken project, there's some version information in this aiken.toml. Whenever you're just coming back into this project, you can just check which version you're using, then probably you're good to go. It's pretty easy to switch version in your compiler also. I remember it's using something like up something. Yeah, I do play around about this for a couple of times, but yeah, every time I play around it, I just navigate the syntax again and again. But it's pretty easy. So whenever you're starting your project, you will have all this information, and you don't have to worry about memorizing anything. Yeah,
Yes.
you just have to rely on the version here, because you know you could do the, for example, build, then you know you're all good with everything here. Syntax is all good. You do the check, you know that most of the stuff are pretty good. So these are
Yeah.
things that you
Okay.
want to know. Yeah.
Thank you.
Good, right? So we very quickly jump into the last bit of today, which is a always succeed maintain validator. So it's the same as the spending validator. You start off with the validator declaration of validator keywords, you serve keyword, and then put in your validator name that you want to use. For example, here I just recycle the same name, because this validator is essentially just the always succeed. But then the only difference about spending and minting validator is that the information it could access is different. So remember, in spending validator, we have 4 different types: datum, redeemer, transaction, and what is it? Yeah, the output reference. This is indicating which is the UTXO you're currently consuming or validating. And we also have the datum, right? But in a minting validator, we don't have those 2 information. So what's the scenarios that we are triggering this script? Is that either you are minting or burning a Plutus token. So at the time of minting or burning, what you want to care about is just the policy ID of it. And there's no such thing as current inputs you're validating, because in the same transaction, there are multiple inputs. There's no kind of indication about which UTXO is relevant. So there's no such thing as output reference in the type signature. Same as datum, because there's no current inputs validating. There's no particular data attached or datum attached with that UTXO. So in the type signature of a minting validator, there's no such thing as datum also. But there's also there's indeed the same redeemer, like there's a user intention, like what the user is intended to do with this redeemer, and also there's information about policy ID. And in Aiken smart contract, I think in every purposes, no matter what is it, there will also be the transaction context provided to every checking. Because in Cardano, the UTXO model or EUTXO model, this is the current transaction that you are validating. If this script fail, the entire transaction will fail. It is not just bound into this current minting, but also the sending value, spending inputs, amongst other things that in the same transaction will fail. So there is a local access to the transactions, no matter you're doing a spending validator or you're doing a minting validator. So put into context, like you could, in the same transaction, unlocking money from a spending validator, and by the same time, you're minting another tokens. So by the same time, you will trigger two scripts. One is, for example, this always succeeds spending validator. There's a first script trigger going to here and evaluate to be true. And then since you're a minting token, there's a second script that you will trigger, like going to script context here and returning the true. And then since you are in the same single transaction triggering, minting, and unlocking, so for the two of the type signature here, the TX in this minting validator is essentially identical to the TX in this spending validator. So this gives you the local access of everything in your current transaction to validate against it. And in no matter which purpose of your smart contract you are using, there will always be the local access of your current transactions. So this is a basic idea about what's a type signature a minting policy will provide to you. It's the same, since this is a always succeed, we could use exactly the same syntax, exactly the same helper function, exactly the same way of triggering unit testing. And then you can see that this is a successful test case on this always succeed minting validators. So I think with this always succeed spending, always succeed minting, this everything that we'll cover today. So before we wrap this session, just check that anyone got any final questions or anything that you want to share, any idea.
Yeah, I have a question.
Yep.
Yeah, I'm still like the output reference. Is it like going to be taken? Is the smart contract, is this contract going to specify the output reference of the UTXO by itself on the on the on the ledger, like on the database, or we are the one to specify it as the programmer? I don't know if that makes sense. Because I was saying something like maybe the smart contract reference into the same UTXO with the output reference, and I don't really get that part. So and the second question is Aiken a case type language? Like I was trying some Aiken, like some codes out, then I was having issues with the uppercase and the lowercase letter, and if you can like give a briefing of that, maybe that would be helpful.
Sorry, I didn't really catch your second question. Is it you talk about the naming convention about variables or?
Yeah, like when giving the variables, some might be like you have to use uppercase, you have to use lowercase, like the redeemer, maybe you might
I
not
see.
use the so.
Yeah, I think I will just attach your second question first because it's just stick to the syntax itself. So in Aiken, it is a language built in Rust. I think in a lot of aspects, they are respecting the naming convention of Rust programming language. So in Rust, if you're naming a variable itself, for example, my variable is following the convention of using snake case, like using underscore to separate the different Rusts, and then it will be everything in the lower case. This is a way that we name the variable in general, but probably it will be perfectly fine if you just ignore the convention. It will just, it could do the same thing. And then the second convention is that about the type. You see that the redeemer is in data type, option type, output reference. This is where it will come into the camel case, but capitalizing the first letter. It is also the same as the Rust type structure. So these are something that could help you to get an idea about what a variable is pointing towards. Whenever you see a uppercase at the beginning as a camel case, it's probably a type. And then whenever you see a lowercase and in snake case, it will probably be a value or a variable to assign some value to it. Yeah, true is a type kind of, so it's also in capital letters. Function is also following, yeah, because there's also a functional language. Variable is just a function, everything is function. So function is the same as variable. We're following the snake case. So this probably could answer your second questions. So about the first question, so what is the output reference of this input? Should we provide it or anything? Short answer is that we don't have to care about it for a lot of the time. This is not something that we should provide about it. So think about the context about when will we trigger this script checking. Is that in Cardano smart contract when you're writing a spending validator script? It's always the time that you try to unlock from the script that will trigger this code block to see whether you are allowed to unlock from one smart contract. So we want to unlock one UTXO from the smart contract. There is a specific pointer about which UTXO you're trying to unlock. So this is the output reference. So in short, is that this thing will come automatically when you try to use the smart contract. For example, going back to this Cardano scan, this is a transaction and this is the output. Just imagine, for example, this output with this amount of value is indeed a script output. For example, this 39.3 Ether is locked in a smart contract in this address. This is, for example, a smart contract address, although it isn't. Just imagine. And in the next transaction, we want to unlock this UTXO from the smart contract. We want to unlock the 39.3 Ethers. So there's indeed a very specific pointer about where this UTXO is in our blockchain, in our ledger. The pointer is called transaction hash output number 0. So this is something that we could load the information in the smart contract itself. Is that when we want to unlock that particular UTXO, this output reference will give you the information about this transaction hash in this number 0. So this is the meaning on this output reference. So for a lot of the time, you don't have to care about this output reference. But indeed, there's a very specific case that you would like to use this piece of information, is that when you try to locate the input from the transaction about which is the current UTXO that you are validating, you will need this piece of information. Like this explanation may be a little bit lengthy, but for completeness purpose, you see that that whenever you are trying to unlock a UTXO from a smart contract, it is definitely an input, one of the input in the transactions. So probably the current UTXO you're validating is inside this list. And then when you check the type signature about inputs, indeed there's a pointers towards which the identity, like the ID of the input. So you could do a very simple filtering about finding the input with its ID. So when you want to use this piece of information, you will probably come into a pattern like this. Current UTXO unlocking from script equals to define inputs. And then there's a ts.inputs we know. It's just the input. What is the single? Oh, yeah, because there's this pattern matching, so I have to use this back. This is a way that you could locate the input from the current transaction by using the input information. So does it answer your question, or yeah, about what it is essentially?
Yeah, like I totally get it now. Like you don't really have to bother about it. Like when you are trying to Yeah, yeah, I get it. Not just to waste like make it lengthy. I think James dropped some guidelines to that. I'll just check on it. So yeah, thanks.
Yep. So same, I will comment these two things, or I don't have to because the naming convention is kind of clear. But I just comment these things. Yep. So for everyone to take a reference, maybe this way. Yep. Any more questions about this? Always a seat. Validators.
Thanks, Professor Hinson.
You're welcome. I'm definitely
Yeah.
it's part-time.
Super good. Thanks, y'all.
Yep.
And
So
what we expect from everybody is that you'll have questions a couple days or a couple of weeks from now. Okay, so Hinson took us on a tour of the code. You know where to find the written lessons, and we'll upload this video so you can review it in the context of those lessons. But anytime you run into questions, just make sure to ask questions directly on the lesson page or in Gimbalabs Discord or in a future live coding session. We're going to keep going through these introductions over the next few months. But then when these intro lessons are done, our whole agenda is going to be defined by what questions people show up with. So make sure to give things a try, get it running on your own. If you get stuck, that's what we're here for. All right, everybody. So we're going to do this one more time next Tuesday, the 17th of December. Then we're going to take a couple weeks off and reconvene in January. So hope everybody's having a nice December so far, and we'll see you next week.
yep.
Bye.
See you all next week.
Thanks, y'all.